That right now. Good morning, good morning, good morning. Hope all is well. Still got a few people connecting. Just give it 1 second. Looks like what majority are in, so we good to roll. So, like I said, good morning. Hope all is well. Everyone's doing all right. Everyone had a great weekend, great holiday. Where's my sheet? There it goes. So, if I'm not mistaken, we're either supposed to be taking a test today or next class, right? Which one did we say? I thought it was today. Everybody, so everybody ready to take it today?
No, you said we were taking the last test.
That's not what I said.
That is what you said.
And then why test 3 wasn't posted?
Huh?
Then why wasn't test 3 posted?
We didn't have class last time.
But we didn't have class last time. But I thought we were supposed to take the test.
You said we were taking. No, you said test 2 was open to the 11th. I didn't hear anything about chapter 3.
And
you said we were proctoring the last exam.
Yeah, okay. I'll let you be the voice of the class today. This time. No, I'll just messing. But yeah, I was a little foggy and I forgot what I told y'all. I got so many different classes going on. So if you were stuck to your guns, I would have had to roll with it anyway because I don't even remember, man. But yeah, okay, that's cool. I'm just making sure that everybody on the same page. All right, thank you for that. All right, so I know last class I sent you guys 3.1, so we will be looking to get into 3.2 today, or is this 3.3? Hold on. Because, if I'm not mistaken, yeah. So we might, we're gonna skip 3.2. We might get back to 3.2, may not, but we're gonna go into 3.3. All right, it's all good. She right. I'm gonna get it to her. Oh man. But yeah, like I said, I won't say I was just messing with it because I know I can. But yeah, I most definitely wouldn't have stood it down, said I was wrong. Cause I don't remember what I told y'all. All right, so we're looking at 3.3 today. Like I said, if we have time to go back to 3.2, then we will. If not, don't worry about it. We'll be all right. Let me see. Did I even post 3.2? Yeah, 3.2 was in the homework, but like I said, you can skip past it for right now unless you just want to do it. All right. Where's my pen? So 3.3, dividing polynomials. Look at the remainder theorem and factor theorem. All right, so let's look at long division and look at the long division process real quick. Just a regular long division process with just numbers. Where my pen? There we go. I'm going to erase this, just walking through the process. All right, so if we want to divide 5,867 by 11, this is how we'll set it up. Have your 11 sitting on the outside, 5867 under your divisional sign. You ask yourself, how many times can 11 go into 5? It cannot, so you don't write anything there, or it goes into 5 0 times. But then we look at how many times does 11 go into 58? And that would be 5 times. Then you say 5 times 11, be 55, and that's what you put right here. Subtract. 58 minus 55 is 3. Bring down 6. So now you say, how many times does 11 go into 36? 3 times. 3 times 11 is 33. Once again, we're going to subtract. 36 minus 33 is 3. Bring down 7. How many times does 11 go into 37? 3 times. 11 times 3 is 33. Subtract. And we have 4 as a remainder because there's nowhere else to go after that 7. And then the way we write our answer is right here. It will be 533. And then 4 over what we were dividing by, which is the 11. All right. So that's our long division process. We're going to take, and the reason why we're going over that is that we're going to take that process and apply it to polynomials. And we're going to follow that same thought process, that same procedure when we get down there to it. So any questions with this before we actually try to use it with polynomials? All right, I'll scroll up. All right, let me erase some of this stuff. All right, so we want to divide x squared plus 10x plus 21 by x plus 3. All right, so we always compare the first terms in each. I have x. Oh, before I do that, notice how we set it up just like we did the 5867 divided by 11. We put this out here and then put this under the divisional sign. So it's the same setup. Whatever we divide and by will be on the outside of your long division process or long division symbol. And then what we divide it into will be under the long division symbol. Once you set it up properly, and this one erase for some reason, there we go. Once we set it up properly, we're going to look at the first term each. We have x and x squared. And you want to ask yourself what times x will give me x squared. Or you can do it like this. Just take the x squared divided by x, and that'll leave you with x. Either way, that's what we're looking for, x. And that goes, I guess I can use red. That's going to be the first part of your answer. And normally you line that up with the same variable exponent. So you put x over x. If x squared was it, then I would put it over x squared over here. You know, whatever your answer is, normally you line it up with that same term. And what's going to happen is that's going to let us know when we're done with the problem because, you know, we only have one more term left. There's nowhere else to go. Well, it doesn't matter though, because this whole thing is reserved for your answers. So if I put x right here, it's not that big a deal. This whole thing is reserved, the whole space is reserved for your answer. But I'm just telling you what they normally do. So if you were to go into the book, they would line it up over the 10x. All right, so Now that we have that part of our answer, we take that and multiply it to what's out here. Okay, yep, not a problem. If you get kicked out, I'll let you back in. Not a big deal. All right, so now you multiply the x to everything out here. Sometimes people make a mistake and just multiply it to the x and don't multiply it to the 3. But that part of your answer has to be multiplied to everything out here, just like that 11. So x times x is x squared. X times 3 is 3x. And we're going to multiply. I want to go purple. All right. So we have x squared plus 3x because we took this x and multiplied to both terms out here. And now this negative sign has to be applied to each term. So a lot of people make a mistake there. Make sure you're careful. X squared and x squared will cancel. But right here, this is now going to be negative 3x because you applied the negative. So that's 10x minus 3x, which is 7x. Bring down your 21. And now we're saying what times x will give me 7x. And that's what we did right here. 7x divided by x is 7. So that's what goes up here. Take the 7, multiply to each term. 7x plus 21. And this minus sign needs to be applied to each. And give us a remainder of 0 because each one of 7x minus 7x cancels. 21 minus 21 cancel. So our remainder would be 0. And our answer is just x plus 7. All right, so we're going to do some more examples of this, but any questions on what we did on this one? All right, I'll scroll up. Okay. All right, so this time we're going to divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. All right, so we set it up same way, 3x minus 2 on the outside. And then notice on the inside, I wrote my terms in descending order. 6x cubed minus x squared minus 5x plus 4, wrote it in descending order. All right. So once again, comparing first terms in each. What times 3x will give us 6x cubed? And that's what we did right here. 6x cubed divided by 3x, because it's 2x squared. So that's going to be the first part of our answer. Notice once again, I lined it up with the x squared. Take that, multiply it to both terms out here. It's going to be 6x cubed minus 4x squared. All right, 6x cubed minus 6x cubed will cancel. Don't forget we have to distribute this negative. And here, be careful because negative to a negative turns positive. So now that 4x squared is positive. So we have negative x squared plus 4x squared, which gives us 3x squared. After you do that, you bring down that 5x and minus 5x. All right, then you say what times 3x will give me 3x squared, and that's what we did right here. So it's gonna be plus x. Once again, take the x or whatever that part of your answer is. This time it is x. You're gonna multiply to each term on the outside. So that'd be 3x squared minus 2x. Distribute the negative. Once again, 3x squares cancel. Now we have negative 5x plus 2x, which gives us negative 3x. And then for our last one, 3x and negative 3x. What times 3x will give me negative 3x, and that's a negative 1. Take the negative 1, multiply it to each out here. And that would be negative 3x plus 2. Negative 3x cancel. This is going to be a minus 2. So 4 minus 2 gives us a remainder of 2. And so this is our final answer right here. We got the 2x squared plus x minus 1. And then with the remainder of 2, so I take that 2 and place it over 3x minus 2. That was what I was divided by. And that's your answer. All right, questions on that? All right. Oh, and ask, can I scroll up? Anybody still copying? All right. All right, so for this next one, we have x to the 5th plus x cubed minus 2 over x minus 1. So notice we have missing terms here. We're missing x to the 4th, x squared, and x to the 1st power. So whenever you have something like that, we need placeholders. You notice what I did right here. I rewrote in my long division process the missing terms with a 0 in front of the x. So I have 0x to the 4th, 0x squared, and 0x. And so what this does is it allows us the ability to step through our process without having any type of skipping or any type of issues. So that's why we use the placeholders to help us with our procedure. All right, any questions before I go and walk through it? Recent stuff, so. All right. So we have x minus 1, and we're going to divide that into x to the 5th plus 0x to the 4th plus x cubed plus 0x squared plus 0x minus 2. Hold on, I'm looking for something. Did I put anything? Okay. All right. So just like before, you ask yourself what times x will give us x to the fifth. So we're talking about, the first term in each. What times x will give us x to the fifth? And that will be x to the fourth. So you take the x to the fourth, multiply it to each term here. X to the fifth minus x to the fourth. Distribute that negative. All right, x to the fifth is going to cancel. Then we have 0x to the fourth plus x to the fourth. Remember that minus sign turns positive because of negative to a negative. So that'll be x to the fourth. Then we bring down x cubed. So once again, we're looking at the first terms in each. At what times x will give me x to the fourth? And that's going to be x cubed. Multiply the x cubed to both terms out here. X to the fourth minus x cubed. So x to the fourth minus x to the fourth will cancel. Distribute. Now we have x cubed plus x cubed. All right, so that's going to be 2x cubed. As always, comparing the first terms in each. What times x will give you 2x cubed? That would be 2x squared. Multiply the 2x squared to each term. So that's 2x cubed minus 2x squared. Distribute that minus sign. Adding these together gives us 2x squared. What times x will give us 2x squared? That's going to be 2x. Multiply that to each. 2x squared, I think it was a minus, right? Minus 2x. These are going to cancel. It's going to turn positive. Add these together, that gives us 2x. And what times x will give us 2x? And that is a positive 2. So 2 times x is 2x. 2 times 1 is negative 2. Distribute. They end up both canceling. And that'll give us a remainder of 0. All right, let me see if I do this. There we go. So that's the whole thing. And that means our final answer is x to the fourth plus x cubed plus 2x squared plus 2x plus 2. All right, questions. All right, am I still copying? All right, so there's another type of division that we can use when it comes to polynomials. It's called synthetic division. So notice you can only use synthetic division when the divisor, that's what you're dividing by, is in the form of x minus c. So what we mean by that is what I have right here. The coefficient, or in other words, the number in front of x is 1, and the exponent on your x is 1. So in the green, the first example, you can use synthetic division. The second one, you cannot because you have x squared in your denominator. And then in the third one, you cannot because you have 2 sitting in front of your x in your denominator. So the only time you can use synthetic division is if it's in this form. In other words, there's nothing in front of x, and then there's nothing on your exponent of x other than 1. All right, questions before we do it? All right, scroll up. All right, so let's talk about how we're going to use synthetic division. Let me erase this stuff. All right, so let's say if we had this as our division problem, we can have the option. Now, if you want to do long division, you can, but synthetic division is shorter. Notice how we set it up. First thing we want to do, if we have x minus 3, we're going to use the opposite sign. So that means we're using plus 3 right here, or positive 3 right here. All right, that's the number that will go in the box. And then from there, you write all of your coefficients. So you have 1 x cubed plus positive 4, well, plus 4x squared minus 5x plus 5. So all your coefficients go right here. All right, any problems with the setup? All right, so first move is to bring down the first number. So that'll be 1. Then we're going to multiply 3 times 1. And that result we'll bring up here. And we're going to add these numbers. So 4 plus 3 is 7. And then we're going to keep that same pattern. So then 3 times 7 is going to be 21. Going to add those together. And I was doing green, so that'll be 16. And 3 times 16 is going to be 48. And then add those together. That'll give us 53. And that last number will always be your remainder. So any questions on that pattern before we look to finish off the process? So you always bring down the first number that you have, bring that down first. And then from there, you multiply the number that's in the box to that number. The result you bring up here, add it to the next number that comes down, and then repeat the multiplication, add and multiplication, add and multiplication, add until you finish. So after you do that, you're going to start with 1 exponent less than the original polynomial. Our original polynomial had x cubed, so we're going to start with x squared. And we use all of these coefficients. So that's how we have x squared plus 7x plus 16, and then 53 over x minus 3. Remember, that remainder always go over what you were dividing by. So we were divided by x minus 3. So you put the 53 over x minus 3. All right, questions? Any questions? All right, let's do another one. So here we want to divide 5x cubed plus 6x plus 8 by x plus 2. All right, so just like before, we're going to use the opposite sign. And let me erase. I'll leave the remainder there. So we're going to use the opposite sign. That's why we have -2 in the box. And also notice we have a missing term. Remember last time we were doing the long division process, whenever we had a missing term, we would use 0 as a placeholder. So we'll do the same thing here. So that's why we have 5, 0, 6, and 8. So any problems with the setup before we walk through the process? All right, so you bring the 5 down, and then you multiply it times -2, and bring that up. So that would be -10. Add those together. The result still -10, but then -2 times -10, +20. Add those together. It'll be 26. That 10 right there. Then -2 times 26. It's going to be -52. I'm trying to stay consistent with my colors. So that'd be 20, 52. Then add these together, and then that'll give us a remainder of -44, excuse me. All right, questions on that? Over here in the purple, I was just emphasizing, probably a classmate or a class member from a previous class was asking why the opposite sign, but that comes from if I were to take x plus 2 and set it equal to 0, and solve for x, then I would get x equal to -2, and that's where that comes into play, and that's going to come into play a little bit later on, but that's where it's coming from. That's why we use the opposite sign here, because of that connection. You know, these being possible solutions for us. All right. So start off with one variable or one exponent less than what we originally had. We originally had x cubed. So that's why you have 5x squared. That's minus 10x plus 26, and then plus -44 over x plus 2. Notice I put the negative up here with the 44. That's the safest way to write it. You could put the minus out here. It's just that when you have more than one term in your remainder, including the negative as a part of your numerator, inside of your numerator, it's just the safest way of writing it. But you would not be wrong if you put the minus sign out here instead of up there in the denominator. In this case, anyway. All right. Questions on that before we introduce something else, and we're going to do another one with it. But like I said, just introducing another thought. All right. So the remainder theorem says that the polynomial f of x is divided by x minus c then the remainder is f of c. So in other words, if you are dividing by x minus c, if you would take the opposite sign or the opposite number, which is what we've been using up here, if I take that -2 and plug it into my original function, then I should get -44. That's what the remainder theorem says. Take this -2, plug it in here, I get out this number. Go back so you can copy. All right, give you a chance to copy that before I go to the next one. All right, so it says given f of x is equal to x cubed minus 4x squared plus 5x plus 3. It says use the remainder theorem to find f of 2. All right. Here, just emphasizing that opposite sign thing that I was talking about earlier. If it's saying f of 2, then that means that you use the opposite sign when you include it with x, so that would be x minus 2 is what we were dividing by. But if it had said f of -2, then that means it would have been x plus 2. It's always the opposite sign that we're talking about. So doing synthetic division, if I just use that 2, plug it into my box, or put it into the box, and then do our coefficients, set it up once again. If it's with x like they gave before, you would use the opposite sign. But if they give it to you like this, you just use the number that they give you. So that's what I'm trying to emphasize right here. Back here, we had x plus 2, so we used the opposite sign. But this time, the way they gave us the information, they gave us f of 2, so we're just going to use the 2 that they gave us. And once again, that comes back to this right here. If it's x plus 2, you set it equal to 0, solve for x, you get the opposite sign. So whenever it's with x, that's when we use the opposite sign. But if they just give it to us, you just use the sign, the number that they give you. So here's the synthetic division process. We bring down 1. 2 times 1 is 2. Add it to -4, that gives me -2. 2 times -4, -2 is -4. Add these together, you get +1. 2 times 1 is 2. Add them together, we get 5. And that last number is our remainder of 5. All right. So that is our remainder. So now the remainder theorem says that if I would have took that 2 and plugged it into our original function, that also should give me 5. And so that's what I did here. Now, when you're doing it on your own, you don't have to do both. I'm just showing you that either way will work. And that's what the remainder theorem is stating. So that's what I did. I plugged 2 into that function, 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. And if you simplify that, that'll go all the way down to 5. All right. Questions on that? Make sure. Make sure we are okay. All right, so last statement right here. Just wanted to emphasize that, we talk about solutions. We've been talking about solutions up to this point, but there are other words that represent the same thing. If you see the word root is another way of saying solution, but also zero, which is what this chapter refers to as solutions as zeros. And that's because the remainder is equal to 0 whenever you have your, what we call zeros or your solutions. So that's what this section is talking about. So your remainder is equal to 0 at these spots. So that's why they call it zeros. But it's the same thing as a solution. So your zeros are solutions as well. What we've known to be solutions in the past are called zeros in this section or chapter. So we just finished the remainder theorem. This is our factor theorem. We let f of x be a polynomial. If f of c is equal to 0, that means x minus c is a factor of f of x. Once again, notice opposite signs here. If it's with x, then it's the opposite sign that you use to plug in to your function. And then b is if x minus c is a factor of f of x, then f of c is equal to 0. So it's just the same. It's the same statement, but said in reverse. And then to make sure we're clear on what a factor is. So if I have x squared plus 7x plus 10 equal to 0, if I were to factor that out, x plus 5 and x plus 2 are my factors of x squared plus 7x plus 10. And then if I were to set those equal to 0 and solve, I get x equal to -5, x equal to -2. Those are what we said before as solutions, but they're also called zeros. They're also called zeros. Reason being is when I plug them into my equation, I'm going to get 0. That also means that when I divide by them, my remainder will be 0. That's why they call it zeros. Any questions? All right. Here I was just showing you that when you plug in -5, you get out 0. Remember, when you plug in a value, you get 0 out. That's what the remainder would be. I'll scroll up. All right, so here they give us solve the equation. You have 2x cubed minus 3x squared minus 11x plus 6 equal to 0, given that 3 is a 0. All right. So since x cubed is our highest exponent, means we should have 3 solutions. And they give us 1, and they tell us 3 is one of our solutions. And so when they say 3 is a 0, these are the 3 things. Oh, my eraser was still on. Okay. These are the 3 things that we can pull from that statement when they say 3 is a 0. So that means if 3 is a 0, that means x minus 3 is a factor of this polynomial. And we're using the opposite sign. If 3 is a 0, that means 3 is also a solution. Remember, those are the same thing. And it also means when I plug 3 into my function, I should get out 0 as a remainder. All right. So I'm going to use synthetic division to break down a function. And so what I originally had before I put all the stuff up there. So when you look at, I drew the arrows from here to here, because if you know that when you plug 3 into your function, you're going to get out 0. Remainder theorem says that my remainder is going to be 0. And then also that's going to be 0. Then you know that -6 has to be right here as well, because 6 minus 6 or 6 plus -6 will give you 0. So those things have to happen. And they told you that 3 is 0. So I'm just trying to emphasize how you can use this information to your benefit. If you come down here, do the synthetic division, and you do not get that result, then somewhere you went wrong, when it comes to calculation, because they said that this has to be the case. If you see a typo, I guess that could be a case as well, then you let me know. But outside of that, because it's a 0, then our calculations have to fit this way. We have to get 0 in our final answer. So that lets us know and helps us to gauge whether we're right or wrong when we're going throughout this process. So try to put this stuff back. Okay, so 2 be the first thing that we do. We bring that down. Then 3 times 2 will give us 6. All right, then we add the -3 and the 6 together. That gives us a +3. Then 3 times 3 is 9. Add them together. That gives us -2. And then 3 times -2 gives us that 6. I keep forgetting to take that off. Give us that -6. 6 and -6 will give us a +0. All right. Any questions on that before we go to the next part? So they told us that one of our solutions was 3. So we took the 3 as one of our solutions. The solution is used the synthetic division to break down our equation. So now we have a quadratic equation. So we can solve the remaining equation, which is 2x squared, plus 3x minus 2. Set that equal to 0 and solve. If you don't want to factor, you can always use your quadratic equation or quadratic formula, I decided to factor 2x minus 1 and x plus 2. Set each part equal to 0 and solve. That's what I did right here. 2x minus 1 equal to 0 gives me x equal to 1/2. X plus 2 equal to 0, x equal to -2. And then also don't forget, they gave you 3 as a solution, so don't forget to include that as a part of your solution set when you give your answer, when you put it in my math lab. Don't just put these 2, they will mark it wrong. You have to put that third one as well, because 3 is one of your solutions. All right, questions on that before we look at another one? All right, you good? All right, so let's do it again. Make sure we're all right. 15x cubed plus 14x squared minus 3x minus 2 equal to 0, and they give us -1 as a 0. So just like before, we're going to use that -1 as a solution and use that to break down the original equation so that we can solve it. We'll do that by synthetic division. Once again, if -1 is a 0, that means the result after synthetic division is done has to be 0. And if I have a -2 back here, that means that I have to have a +2 at the end in order for me to get 0. Bring down 15. 1 times -1 times 15 is -15. Add those together, that gives us -1. -1 times -1 is +1. Add that to the -3, that gives us -2. Then -1 times -2 is +2. Add those together, we get 0. Right. Any problems? All right, so we use the 15, -1, and -2 to set up the next part of our equation or process, basically the breakdown of what we had originally. So that's 15x squared minus x minus 2. Factor that out. to 5x minus 2, 3x plus 1. Solve the equations. And there are my 3 solutions. All right. Any questions? Any questions? All right. Okay. So that's it for 3-3. Questions on anything I've done? We'll at least touch on 3-4. All right. So 3.4 is called zeros of polynomial functions. Not sure if we're going to do all of this today. We'll see. Anyway, so zeros, don't forget, another word for zeros, roots, and then your solutions. So we're really looking at solutions of your polynomial functions. All right. First thing is your rational zero theorem. So basically to find all possible rational zeros. So basically, if you have a function and you start from scratch, they didn't tell you that 3 is a solution or 3 is a 0. This will help you create a list of your possible solutions that you'll be able to try, plug it in synthetically, use synthetic division, and then you'll be able to figure out which one is a 0, which one is not, and start from there. So remember, once you get this list of possible solutions, you can plug into your equation. If it equal to 0, then you know that that is one of your solutions. And then you can start from there as far as breaking down your equation. So here I've just given you a small example as to why they came up with that. So you take plus or minus the factors of your constant, place it over the factors of your leading coefficient. So here your constant is always the number that's not associated with the variable at all. And your leading coefficient is the one that has the highest exponent on your variable. And so when we solve this, notice how we get the 3 over the 2. And so that's where that's coming from. So that gives you a list. When you do this generically, you get a list of all of your possible solutions. So everybody cool with that before I scroll up and see how it works. All right. So here we want to list all possible rational zeros of f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. All right, so notice I already labeled it. The 2 is your constant. 15 is your leading coefficient. Once again, the number that's not associated with a variable at all is going to be a constant. The number that's associated with your variable with the highest exponent will be your leading coefficient. So then we look at all of the factors of 2 and then all of the factors of 15. So factors, 2 is just 1 times 2. 15, two numbers that multiply together to give 15. That's 1 times 15 and 3 times 5. So then we're going to take each one of our numbers from our 2 and place it over each one of the numbers from the 15. And that's what we did here. 1 over 1, 1 over 15, 1 over 3, 1 over 5. Then 2 over 1, 2 over 15, 2 over 3, and 2 over 5. And this plus or minus applies to each one. So you simplify that list. What do I have over here? Okay. So simplify that list. That's 1, 1 over 15, 1 over 3, 1 over 5. 2, 2 over 15, 2 over 3, and 2 over 5. And notice that's 16 possible numbers here because this plus or minus applies to each one. I'm just shorthanding it. but it's plus or minus 1, plus or minus 1 over 15, plus or minus 1 over 3, and so on. So that's 16 possible numbers here. All right, questions on the process before we do it again? Make sure we're okay with what we've done. And then, like I said before, just re-emphasizing what you would do with this list. If you don't have any idea as to where to start, you know that there are 3 solutions. All right. So you don't know where to start though. If I can erase this. Why is this not erasing? There we go. So what you would do is you'll start with +1, plug it into the function, see if you get 0. If you get 0, there's one of your solutions. If not, then you go to the next one. Then you use -1. Then you take 1 over 15, plug it in. Then use -1 over 15 till you get at least one solution. Remember, when you plug it in, get out 0, that's one of your solutions. Then from there, we do the last thing that we did, which was use synthetic division to break down the equation and find the rest of our solutions. All right, so here we're going to do the same thing. We have 4x to the 5th plus 12x to the 4th minus 6, minus x minus 6. So we look at the factors of 6, which is our constant. Then our leading coefficient is 4. So we look at the factors of 4. So 1 times 6, 2 times 3. 1 times 4, 2 times 2. Then we take each one of our factors of 6 and place it over the factors of 4. Let me erase this. All right, so that'll be 1 over 1, 1 over 4, 1 over 2. You don't have to write the 2 twice. We have 2 twice right here. So 1 over 2 and 1 over 2 are the same thing. So we don't have to repeat that. So then you take 6. 6 over 1, 6 over 4, 6 over 2, 2 over 1, 2 over 4, 2 over 2, and then 3 over 1, 3 over 4, 3 over 2. You take the factors of your constant and place it over each one of the factors of your leading coefficient. All right, and then you're going to simplify. You got 1 over 1, which is just 1, 1 over 4, 1 over 2, 6. 6 over 4 reduces down to 3 over 2. 6 over 2 reduces down to 3. And so you'll eventually get down, you got 2, but then 2 over 4 is 1/2. So we don't have to repeat that. 2 over 2 is 1. Don't have to repeat that. 3 over 1 is 3. The same thing as 6 over 2. We use 3 over 4, but then 3 over 2 is already right here, 6 over 4. So you don't have to write any repeated values. And once again, we have 16 possible zeros because that plus or minus go in front of each. All right, questions. All right. So let's see. Possible. Yep. All right, we'll do that. All right, so here it says find all zeros. We have f of x is equal to x cubed plus 7x squared plus 11x minus 3. So our constant is 3. Leading coefficient is 1. So first, we're going to find all possible zeros, which is what I did right here. So I took 1, placed it over 1, took 3, placed it over 1. Only have 4 possible solutions. So make sure we're okay with that before we go any further. All right, so once we have our possible solutions, we can use synthetic division to see which one is a solution, or we can plug it into the function to find 0. I just walked through the synthetic division option just to to reemphasize the process, make sure everybody's comfortable with it, to practice. Make sure everybody's practicing synthetic division. But the other option is to plug it into the function. Remember, your goal is to get 0 as a remainder, or when you plug it in, remember the remainder theorem says that when you plug it in, you will get 0 as a remainder. So either one, as long as you're getting 0 out, that lets you know you have a solution. So let me erase at least some of this stuff. All right, so we're looking at coefficients 1, 7, 11, and -3. Bring down 1. 1 times 1 is 1. Add those together, that'll give you 8. 1 times 1 is 8. Add those together, that'll give you 19. 1 times 19 is 19. And you add those together, that'll give you 16, which is not a solution. It's not 0, because remember, we need 0 in order for it to be a solution. Once again, if I were to take this 1 and plug it into that original function, I should have gotten out 16. So I did the same process here. Using -1. So you bring down 1, -1 times 1 gives you -1, add them together, you get 6. -1 times 6 is -6. Add these together, you get 5. -1 times 5 is -5. Add these together, -3 and -5, you get -8. So once again, not a solution. As soon as we get 0 right there, then that'll let us know that we have a solution. Oh, this one not 1 either. All right, so it just so happened that the last one that we had ended up being a solution. So if you did 3, bring down 1, 3 times 1 is 3. That gives us 3. Add them together, that gives us 10. 3 times 10 is 30. Add them together, that gives us 41. 3 times 41 is 123. Add these together, we get 120. Then the last one, using -3 and walking through the process, we finally get 0 as a solution. So once again, I just did each one of them using synthetic division. I wanted to emphasize the synthetic division process. What you could have easily done was taking each one of those and plugged into your original equation, which is where we're at, which is this one. And you would have gotten your results, 16, -8, 120. Then you would have got 0 when you plugged in -3. And then that will let you know that's one of your solutions. All right, so before we go to the next step, any problems with what we did there?
Do you mind scrolling up real quick? I think I miscopied the question.
Oh, all the way to the top of that question?
I just want to double check.
Yep. So the question is just in black.
All right, got it. Thank you.
All right, not a problem. Anybody else still copying before we go to the next step? Make sure we're okay. All right. So just like before, take this part, and that is the result of breaking down your equation. Now, I will say this though, once you have found your solution, you do have to do synthetic division in order to break it down. So at some point you will have to do synthetic division, but you do not necessarily have to use synthetic division in order to find your zero, but you do have to do it once you get it. So that gives us x squared plus 4x minus 1. So we cannot factor that, so you have to use the quadratic formula in order to find your solution. And that's what I did here. A is going to be equal to 1, B is 4, C is -1. All right, then plug it into this formula, negative b plus or minus square root of b squared minus 4ac over 2a. And there's your breakdown, plugging in 4 for b, 1 for a, -2 for c, under the radical. 4 squared is 16, 4 times 1 is 4, but we have that negative, so it's negative turns positive. 16 plus 4 is 20. Now we can break down that square root of 20. That's what I did right here. So break that into 4 times 5. Square root of 4 is 2. So you bring the 2 to the outside, leave the 5 under the radical. Then we can simplify this all the way down by taking that 2 and dividing it to each term. And that gives you -2 plus or minus square root of 5. All right. Questions? Any questions? So notice right here, your 3 answers, -3, -2 plus square root of 5, and then -2 minus square root of 5. All right. Any problems with that before we look at another situation? All right, so the complex conjugate theorem, if a plus bi is a solution of f of x, then a minus bi is also a solution of f of x. So if you have an imaginary number, they come in pairs, in other words. So 4 plus 5i, if 4 plus 5i is a solution, that means 4 minus 5i is also a solution. If -2 plus 7i is a solution, that means -2 minus 7i is a solution. And also -8i and +8i will also be solutions that come together. Sorry about that. All right, any questions, any questions? All right. So here's the next problem, or next type of problem. Find a fourth degree polynomial function with real coefficients that has -2, 2, and I as zeros, in other words, as solutions. And also when you plug in 3 into the function, you get out -150. So we have multiple initial conditions here that we have to meet. But they give us the solutions and they want us to they want us to give the equation that will produce these solutions. So we're working in reverse of what we normally have to deal with. Normally they give us an equation, they want us to find the solutions. This time they give us the solutions and they want us to find the equation that produce these solutions. And that's what I wrote in the green. They give solutions and want to know what function produced the solutions. Also right here, this does not say that 3 is a solution. It's just saying that when you plug 3 in, you get out -150. Remember, if 3 was a solution, you would get out 0. So 3 is not a solution. It's just saying when you plug 3 into the function, you get out -150. All right. So let's talk about what information they give us in total. So fourth degree means there should be 4 solutions altogether. They give us 3. That means we're missing one as far as initially what they gave us. And so right here will be all 4 of our solutions. Don't forget, we just mentioned the complex conjugate theorem, saying that if I have an imaginary solution, that means there has to be 2 of them. They come in pairs. And the difference between one and the other is just that the imaginary part is the opposite sign. And going back there, that's all that happened. Here's that the imaginary part was the opposite sign. The real part was the same. And why is this not erasing for me? All right. And then same thing happened right here, even when we had just a single imaginary part, then that sign is what changed. So here we have positive I, so that means negative I is that 4th solution. All right, any problems with that? Okay, so we have -2, +2, I, and negative I. Now, when we go back, and remember we're doing the reverse of what we originally had. So if I have x equal to -2, but I wanted to reverse the process of it not being a solution, when I take it back to x, remember we talked about this already, that would actually be the opposite sign, which is x + 2. In order for me to get x equal to -2, I first had to have x + 2. So I have to use the opposite sign. So when I go to set this up, this is how it was set up. Reverse engineering my function. So notice I have an a sitting out front because there may be a number that's sitting in front that I have to give an account for. So for right now, I'm just going to call that a. So that will be always what we do. Then also, I would set each one of these up with a negative in front to signify I'm using the opposite sign. So I have x minus -2, x minus 2, x minus I, x minus negative I. And that's going to matter when we have multiple. I'll show you later. I think I got one back here. Yeah, I believe so. But that will matter. So setting it up this way is the safest way to set it up. You use x minus whatever your solutions are. And when you simplify, this is what we have: x + 2, x minus 2, x minus I, x plus I. All right. So now the best practice is to multiply these together, then multiply the imaginary ones together, versus trying to, doing these two together or anything. If you multiply the imaginaries, they will cancel out some things and make things simpler for us. So we'll just do it that way. We have our conjugates that we will be multiplying together. What do you call conjugates? I'll just leave it at that. All right, so gonna fall out this x times x times -2, 2 times x, 2 times -2. Same thing here, x times I, negative I times x, negative I times positive I. All right, so this would be the result. So if x squared minus 2x plus 2x minus 4, x squared minus ix minus ix plus ix minus ix minus I squared. So then we notice our middle terms would cancel. So that's what I was talking about, things canceling out for us. So you always want to multiply those imaginary expressions first. Also, don't forget that I squared simplifies to -1. So that expression reduces down to this, a times x squared minus 4 times x squared plus 1. Pull that out. That'll give us x squared plus x, or x to the 4th plus x squared minus 4x squared plus, minus 4. And then combine your like terms, we have x to the 4th minus 3x squared minus 4. So we're not finished, almost finished, but we still have this a sitting out front. We have to see if there's a number that's going to be in the front of this expression before we close it out. Because remember, we have an initial condition that when I plug in 3, I get out 150. It's either 150 or -150. Yep, -150. So we have to explore, will that happen in its current state? If not, then we'll be able to solve, put a value in there for a. That will make that happen. All right. So plug in 3. This says when I plug in 3, I get out -150. So that's what I did right here. We're going to plug 3 into this expression. So that's what happens right here. So wherever I see x, I plug in 3. So that's 3 to the 4th, which is 81. 3 times 3 squared, which is going to be 27, because 3 squared is 9. 9 times 3 is 27. And then we have minus 4. 81 minus 27 minus 4 is going to be 50. A times 50 is the same thing as 50a. So now solving for a, divide both sides by 50. That'll give us a is equal to -3. Almost finished, almost finished. All right, so now we put the -3 back. Not back, but we put the -3 in for a into our function and distribute. And that will be our answer. -3x to the 4th minus 9a squared, 9x squared plus 12. All right, questions before we look at another one? All right, can I scroll up? Am I still copying? I think this is the last one. Yep. All right, so this next one, similar process. I just wrote shorthand what the directions were. So this time we have a third degree polynomial. So in other words, 3 solutions. They give us the solutions or zeros, which is -5, -5, and 4 plus 3i. And then here, when I plug in 2, I get out 91. All right, so we're gonna look at our zeros first. Once again, don't forget complex conjugate theorem. If I have an imaginary theorem, they come in pairs. Imaginary solution, they come in pairs. So if 4 plus 3i is a solution, that means 4 minus 3i is also a solution. So we have 3 solutions here, or 3 solutions, -5, 4 plus 3i, and 4 minus 3i. All right. So now put that in with, erase some of this stuff. So if you put that in with x, remember we have to reverse engineer or reverse the solution process. They give us solutions and we want to go backwards and figure out what function gives us the solution. So the first thing we put in is a, remember, because there may be a number that sits out there that will help us to get this initial condition right here. And then each one of our solutions, we do x minus that solution. So x minus -5, x minus 4 plus 3i. Notice I put parentheses around the 4 plus 3i. Then x minus 4 minus 3i. I put parentheses around that as well. All right. So negative to negative turns positive. Then this negative right here has to be distributed, and this negative has to be distributed to each one of your terms in your parentheses. All right, so just like before, go ahead and multiply the imaginary, the parentheses that contains the imaginaries, so that things can cancel out for us. And we're going to go ahead and distribute, all 3 times. We have x times x times -4, x times 3i, x -4, do your distribution and distribute at -3. And that will give us this result. All right, I think I got kicked out for a second. So I didn't say anything, I paused, got a message. All right, so hopefully everybody can hear me okay now. So we have a times x plus 5. Then we have x squared minus 4x plus 3xi minus 4x plus 16 minus 12i. I ran out of room, so I wrote down this next part down here. Minus 3xi plus 12i minus 9i squared. So any problems with that before we look to combine like terms? All right, so positive 3xi, negative 3xi will cancel. Negative 12i, positive 12i will cancel. So you combine your like terms that are left. That -4x and -4x will give you -8x. Also, don't forget that I squared is -1. So that'll be a +9, which will give us +25, when you add it to the 16. -9 and -1 is a +9, plus 16 will give us that +25. Any questions? I messed it up. All right, so now that we have this, we can go ahead and distribute again. Take x, multiply it to each term. Take 5, multiply to each term. That gives us this result. X cubed minus 8x squared plus 25x plus 5x squared minus 40x plus 125. Then you can combine your like terms. -8x squared plus 5x squared is -3x squared. Positive 25x, -40x will give you -15x. So that's our most simplified expression up to this point. So now we need to figure out if a number goes in for A. That will help us with that initial condition. So any problems? Can I scroll up? Everybody okay? All right. So the initial condition that they gave us is when I plug in 2 into the function, I get out 91. So that's what I did here. Took 2, plug it into this expression right here for x. Remember, it's supposed to equal to 91. So 2 cubed is 8. 3 times 2 squared. That's 3 times 4, which is 12. 15 times 2 is 30. So we have 8 minus 12 minus 30 plus 125, which will give us 91. And so we take that, A times 91, 91 times A, divided by 91, A is equal to 1. And so this means that, essentially there wasn't anything that was going to change when we plug 1 in for A. And so that'll be our result. Remember before we had a -3 that we had to plug in and then distribute, but 1 times anything is itself. So A being equal to 1 doesn't change our expression. And that is our answer. Any questions? All right, any questions, any questions? All right, so that's 3, 3, and 3, 4. Make sure you guys are trying this stuff out and see if you have any questions. Every day is an opportunity for questions. Every day is an opportunity for me to do something that you may have tried, got stuck on, or you just want to see me do again. So make sure you take advantage of those times so that we can make sure you're good moving forward. Don't forget that whatever test you take, you should be sending me your scratch work. So don't forget to do that. And this is September. We only got a couple weeks left, like 3 weeks. 3 weeks. So make sure you guys are staying on top of this stuff. And knocking this stuff out as you progress throughout the course. Before we close out today, are there any questions?
I didn't know we were in September.
Huh?
I didn't know we were in September.
Is that what I said?
Yes.
Yeah. You know what I meant.
I just wanted to get to you from earlier.
I noticed what you were doing. Yeah, but of course, we're not in September, guys. We're in July. And it's like I heard myself say it, but I was just like, I'm gonna just power through it. I'm gonna just take that L. So yeah, we are in July. We are in July. Anything else? Anybody else before Ms. Chambers take another shot at me?
When is the test again? The last day?
The
Is
last.
it the 10th
No,
or
you talking
11th?
about the last test, or you talking about the one that's due for chapter 2?
Chapter 2. Is it for the 10th or the 11th?
It should be the 11th. I try to make my due dates on a Sunday.
Okay, thank you.
Yep, not a problem. All right. Anything else? Anybody else? Everybody good? All right. Don't forget, don't hesitate to shoot me an email if you have any issues, or like I said, or next class, feel free to ask them. And like your classmate just mentioned, we have our stuff from chapter 2 that'll be due this Sunday. So yeah, make sure we're knocking this stuff out. If you have any issues with submitting anything, any life issues happen, make sure you email me so we can make sure that you have a plan moving forward on getting caught up or getting an extension. So you don't want to take zeros if you don't have to. Other than that, you guys have a good one. Be safe, and I will see you on next class.
Have a good day, Professor.
Thanks. You do the same. Appreciate that.
Hi, Professor.
Take care. Thanks.